Um, so let's quickly finish up the um, last part of a 6.3, which is half angle identities or half angle formulas, which I believe I already showed you last time. So now, I mean, let's be practical. So if you guys have the cheat sheet with you, that single sheet with front and back, right? So those are the identities that you guys better memorize for our third test, right? But I said, don't feel like it's too many because, it's just that I try to make them big enough for you to see better. Now, if you take a look at, I mean, there's not even front and back, whichever side it is, you have the double angle, power reducing, right, half angle identities, and those three are the half angle. And I'll show you how to use them. Now, so the questions in the test might be, even very straightforward in, the instruction. So make sure that, when you're taking a test, read the instruction, because they'll say, for the following problem, use half angle formula to do this and that, right? So that means you know what to use, right? But, of course, you don't have to memorize these things. But sometimes they might not be that straightforward, and that's why you're going to see later that. But the thing is, you see that those names are very intuitive, right? They pretty much tells you that what you can achieve using those identities. Half angle, right? That means you're going to get those functions evaluated at half of an angle, assuming that you know what that angle is, or maybe you have some nice conclusion about those angles. But for some reason that you want to know, what if I take half of the angle, right? Will I get something that could be worked out, fairly easily? But the catch here for these formulas, and that's why you have to be super careful, is that you have plus or minus signs. And you cannot just tell me, oh, this guy's going to be either positive or negative. As a final answer for a problem, you have to make sure that you pick whichever sign you have to use. And the way it works is to use the quadrant conclusion. Right, so let's take a look at one of the examples in the book. All right, let's see how that quadrant thing works out. And also, let's say, forget about, the instruction on top, right? What if you see a problem like this in a test? How would you know that it's asking you to use the half angle? So they say, we have some knowledge of cosine 210. Right? So we need to figure it out, cosine 105. So you know that we have from 6.1 to 6.3, right? Tons of identities, right? That means there's gonna be a lot of problems in the test asking to either use the identity to prove, to verify, or to evaluate things, right? Therefore, hopefully you realize that 105 seems pretty small, right? And it turns out to be smaller, or twice as small, right, as 210. Therefore, I mean, what you should do is to just go ahead and write down what the half angle identity or half angle formula looks like and go from there, right? So what is the half angle identity? Well, since we're evaluating the cosine 105, right? So we better use the one that has cosine in it, right? So it's going to be this one, cosine alpha over 2 is equal to plus or minus square root 1 plus cosine alpha over 2, right? So while you're probably seeing me looking at the formula sheet, I'm not pretending that I'm a student right now because I seriously couldn't remember the half angle. And why should we do that, right? So again, you have one good reason to do it now because that's for the test, right? So don't feel bad if you couldn't remember this because it is hard. But now let's say you have this formula, right? I mean, what could be the alpha? 210 is gonna be it, right? So, wait, is it too simple? No. Right. So, or at least that is probably too obvious, but hopefully, no. Okay. My bad. All right. So half of 210, right? Let's take alpha to be 210. It will be plus or minus square root 1 plus cosine 210, right, over 2. Then you realize, 210 over 2 is 105, right? So this is nothing but cosine 105. So now the question is, okay, now you don't have to worry about the plus or minus right now, but you're gonna have to do it. So the question is, how much is cosine 210? Good. All right. So I'm sorry that I sometimes always bring the bad news. I don't have too much to say, since I'm only 1/4 of the group. So I saw in an email this morning from one of the instructors, right? And I didn't look into the detail because I was busy with the, the lesson plan for the calculus class. So they're thinking about not having you. Well, yeah, I'll definitely speak up. We already told you guys, you're allowed to use the scientific calculator, right? Let's keep it that way. Okay. But like I said, well, at least the worst case scenario is, we have to come to an agreement. If I'm the one who insists I don't agree with, right? So then they have to talk me into it. But anyway, I mean it, because like I explained to you in the past, my background says that I don't see any point of not using a calculator for questions like that, right? So I'll explain to them, with my logic. But I'm saying that, so be aware of, right? So, or at least that if you could, that try not to spoil yourself too much, with the calculator. Hopefully that later it will be a blast, in a test that you can still use it. But let's say you're not wrong if you want to just type in the calculator, right, and get a cosine 210, right? So can somebody do that for me? How much is cosine 210? 210 degree. All right, so I'll still keep it plus minus. Square root 1 plus. Okay, so negative square root 2 square root 3 over 2. Okay, that means it's 1 minus root 3 over 2 over 2. Okay. Now this is why sometimes, I think that it's probably not a good idea, to just do only algebra, because you see that now you have to get a radical on a radical, right? If you were to keep it like that. So I think that would be nicer to be, in a decimal form. But let's say whatever it is, right? You can always figure out, the actual value. But the question is, which sign should we pick? No, that's positive. One is greater than radical 2 over 2. So you can get a positive number on a radical. So it is, a real number. But hey, what quadrant do you think that 105 is in? Second, right? So now you remember a smart trig class, right? So in the second quadrant, only sine and its reciprocal, which is cosecant, right, are positive. So cosine 105 must be negative. That means that now, I don't know what's going to happen in the test, whether or not you get to use the calculator, but at least if you get a result that you don't have a calculator and you somehow, figure out a way to show me that you do understand the identity, you show me the identity correctly, right? But if you somehow didn't figure out the correct sign, you're going to get points off only for the sign. If you get something wrong, let's say how much that is. You guys have a so let me get the value and I'll tell you, right? So that's a valid question. So cosine, well, that's that's too hard for me. Okay, that's, yeah, can I have, thank you. So I need 1 plus that, let's say 1 minus. You have it? Yeah, so can I just have the decimal here?
Oh, the decimal?
Yeah.
Yeah.
It's 0.06,
Oh,
right?
it's that. Sorry.
Okay, so 0.26. All right, so it's negative, right? It should be negative 0.26. But that's assuming that you have the calculator, right? So let's say the student showed me this, right? And the corrected substitution. Now at the end, instead of getting negative 0.26, the student got let's say 0.3. Or you know what, make it even worse, 0.5 and negative. So instead of having negative 0.26, the student got negative 0.5, right? If it's FRQ, typically I have 5 points for an FRQ, right? I'll take 2 points off. Oh, sorry, 1 point off, because the answer is not right. So you get 4 out of 5, right? Hopefully you figure it out with or without a calculator, right? Or if you don't get to use the calculator, at least get the number right. But I think that's not going to be a big deal, getting 4 out of 5, right? But yeah, you want. So that's what I'm gonna get to in a second, right? But let's make it worse than that. So let's say the student no, I'm saying that what if the student screw up the sign? You know what? Now I'm thinking about oh yeah, but sometimes I think that because they're using the special angles, they don't necessarily tell you how much cosine 210 is. And you know that the reason this is different from the test problem is this is in the book, right? The test problems, like I say, you might not be given a special value to play with. So since that one of the most important learning objective for this problem is people know how to get the correct sign, right? So now since this is almost half the problem, right? If I see that the wrong sign, I'm going back and see, okay, I do see the correct identity and a correct substitution. I'm giving 2 out of 5 because the rest of the thing is just wrong. I can even assume that you don't even care about the value because I don't care about the value, right? Because I have the calculator. Why would I care about something that's just typed into the calculator? But what I do care is the negative sign, and I don't get it, right? So that's how bad it is not to get the right sign. Okay. But like Karina says that if you're lucky enough to have that result, right? That means you don't need the calculator. And you know what? If you could at least get me the right sign. Let's say the student just choose to leave the answer like that. How many points do you think I'm going to give? Yeah. Yes. Because to me, it's right. Right? I don't see any point of simplifying it. So now you see the idea of working it out, sometimes even without a calculator, because you have to know how to do it, right? And the calculator is going to be only the last step. If you do care about a number, right, you can figure it out. But that's not our focus. But sometimes when it comes to the sign, it might be a bit trickier than what you see here. In this case, everyone can figure out the negative sign because it's in the second quadrant, right? Cosine has to be negative. Oh, let's see. One of the quiz question. Well, I'm not going to walk you through, since you're going to have to do the quiz on your own, right? But let's say, take a look at 29. They're telling you sine theta is 1/4. Tangent theta is positive. So you need to figure out cosine half of the theta. Hopefully you see that this is just yelling at you, please use the half angle, right? They didn't say that, right? Use the half angle, write down the formula that I showed you, right? Cosine half of the angle. But let's figure out the sign. Should the answer for cosine and theta over 2 positive or negative? Based on what they have told you. Some say positive. Why is that? Good. That's actually the reasoning. All right. So now, please show me that, because if it's FRQ, I would like to see all the reasoning. So just in case we mess up something later, but when I see those, I mean that I'm more towards giving most of the points, right? Yes, the theta is the first quadrant, so half of it's going to be even more in the first quadrant, right? There's no reason to get any angle beyond that. That's why no matter what you get for cosine 2 theta over 2, the answer has to be positive. Okay, but I hope that with the identity, right, once you write it down, once you see that you need cosine theta, right, you guys remember that? No, I can write down the identity for you. Cosine theta over 2 is plus or minus square root 1 minus 1 plus, right, cosine theta over 2. Do you see that you need cosine theta to figure it out? How do you find cosine theta? Then why do you think that they tell you sine theta is 1/4? The triangle thing, right? Write the triangle, right? Label the sides, figure out what the cosine theta is, right? Plug it in, and if you can do the algebra, right, get it right with the correct sign, you get full credits. If you mess up the algebra, at least that show me the correct formula, right? The substitution, the triangle with the correct sign, leave the answer in the ugly form, you still get full credits, right? Because I'm evaluating the learning objectives, right? I'm not crazy about simplification at this point. Now, what about 30? I can write down the identity for you. Sine theta over 2 is plus or minus radical 1 minus cosine theta over 2. Right? So it looks like that we do need the cosine theta. How do we figure out cosine theta? Triangle. But does it bother you that the triangle is going to have negative sides? Not at all? Okay, so then, well, in this case, that cosine theta has to be negative since the theta is the third quadrant, right? But the question is, how would you find out cosine theta with the right triangle where you have actually negative sides? Go ahead, Max. So I said that, since there has to be some negative sides, right? Well, because the only way you can get negative ratios is have the opposite to the hypotenuse, right? So one of those sides has to be negative, right? But since Max says that you're gonna square, I'm assuming that you are getting the cosine out of the sine using the Pythagorean identity, right? Since you're gonna square the sine anyway. Now, I believe that what I said in class is you could forget about a negative sign at this point and still label the sides as you should, right? 3, 5, and the missing side has to be 4, right? So now when it comes to cosine, well, it's not just 4/5. It has to be negative things that the theta is in the third quadrant. As if that you only deal with the negative sign when you have to, right? When it comes to right triangle, why would you need negative signs, right? Now, that's the first catch here. The second catch is, once you plug it in, right, be careful with the sign flip, right, because it's subtracting negative. Then again, what will be the the final answer? Will it be positive or negative? I need the reasoning. That's in the third quadrant. Fourth quadrant, my bad. Theta is in the fourth quadrant, right? But that's theta. What about theta over 2? No, the thing is, the plus or minus possibilities come from the fact that the angle theta over 2 might not be in the first quadrant, right? And some of the trig functions might be negative, okay? So, you guys know the range of an angle in a fourth quadrant? What kind of range do you think the angle has to fall into to be in a fourth quadrant? Okay, greater than, or let's say greater than, right? 270, less than 360, right? Okay, so that's theta, right? So what about half of it? How much is this guy? 135? 175 less than theta over 2, less than 180. What kind of quadrant is that? That's in the second quadrant. So therefore, sine of theta over 2 is positive. That's why I'm saying that. That's the second catch. Okay, so you have to get the sign correct. You see that it actually matters. Yeah. Just keep an eye on the recording. You see that first catch is also kind of important. If you mess up the sign, you guys see that the algebra is not gonna work out, right? It's 1 minus cosine. If you get a positive cosine, it will be very different from a negative cosine. That's the first catch, right? But I mean, if you're not gonna get, the exact number since you don't have a calculator, right? I'll forgive you as long as you give me the correct sign at the end, right? So sine of theta over 2, and you have to show me some kind of reasoning, right? Why you're going with a positive or negative. In this case, you're going with a positive since that you see when theta has to be in the fourth quadrant, half of theta has to be in the third quadrant. Or, let's say that if you don't like to do this kind of reasoning, at least you tell me that because of theta over 2 is in the second quadrant, therefore sine of theta over 2 has to be positive. Okay, I need something to be able to evaluate your work, when I'm comparing to all the learning objectives. Okay. Now, are we good with the half angle? At least that is just 2 more identities, right? And now you see how that works out, right? But unfortunately, there are 2 different versions. There are 2 more versions for half angle if you're looking at half tangent. You see how different it is if you have the tangent half of the angle from the original version with a plus or minus. Take a look, right? It's plus or minus radical 1 minus cosine over 1 plus cosine, right? For some reason, if you're curious, talk to me in office hour, I'll show you. But we can show, we just don't have the time for it, but we can show that tangent half angle could be those 2 without the plus or minus. That means that we do see the benefit of having these 2 additional forms, is that you don't have to worry about the plus or minus anymore. But it has to be tangent half angle. It doesn't have, we don't have the formula for, sine of half the angle, cosine half the angle without the plus or minus. Okay, these are the only 2 exclusive for the tangent of half angle. But to be honest, so when I get a chance, I'll show you my cheat sheet back in high school. But those 2 are the ones that I have to memorize before every single test. Not really, but just in case. But the reason why I have to memorize right before the test or before every single test is, unless I want to spend like a minute to derive them, I could in a test, but I don't have the time to do it, right? It's so hard to even predict what you should get. Do you see that these 2 are so close to each other in a form, right? Some have 1 minus cosine, some have 1 plus cosine. One is at the top, the other is at the bottom. If I ever messed up one little thing, I'll get it completely wrong. That's how bad those identities are. And that's why, we need reference sheets in SAT, right? So there are things that you just have to know, right? And it is on the cheat sheet I gave you, right? I don't know if you guys will search to memorize these two. But like Joanne asked me, like, did I ever end up using them back in my old days? And it didn't happen, even when I have to take the test, right? Even in a much, more demanding, environment, because at that time we don't have calculator. It's not even an option, right? We have to just figure it out. And I don't even remember. Maybe I did once or twice. I never remember that I ever used those two guys. Okay, so that means, are you gonna? It's like, are you gonna worry about not winning a lottery, so you never buy the lottery ticket, right? Or will you worry about getting hit by the lightning, so you never go outside when it's raining? No, right? Those are small chances, right? So like, you almost never gonna be able to use those two identities, right? What would you worry about? If you wanna risk it, don't remember those two, it's up to you, right? But you know that what I'm gonna say is, if you end up being already remembering 50 identities, why don't you go with 52? Well, there are 52 states, right? It's just two more, right? But be careful with that, because if you do that, I'm gonna ask you to remember more and more, because hey, you already remember 52. How about go with 60, right? But that's the way your coach is gonna tell you, right? Do 10 push-ups. Don't stop until I tell you to stop, right? Do 15, right? And before you realize you did 100, right? Anyway, anyway, so now, but guys, seriously, I don't know when you guys gonna be coming to do the quiz, but at least that after today, you're gonna have to seriously start reviewing all the questions in the packet, and at least that, based on what we have talked about in the, just now, you should be able to try all two problems. You know that those problems are a little bit more involved than normal, right? So you have to maybe figure it out using the, right angle tricks, right, to find out what you need, and also be careful with the size, and also test yourself. See if you're able to memorize those identities. Okay, do it once today and do it, one more time for tomorrow. And our test might be, sometime next week. Like I said, it's just front and back, right? Yeah. Yeah. You're better off remember everything. All right. So let me move on to 6.5. It's just that now when you're thinking about the test, gonna cover 6.5, and you can even tell from the topic, right? Equations, right? Trig equations. Solving for the equations is always gonna be more intensive, right, in algebra than all right. Now there's not much, we have to learn, additional, but it doesn't mean that you don't have to take it seriously, because it might be hard once you learn 100 things, but you have to like put them together, right, and figure out. But maybe it's not as bad as you thought if you have the right tool, right? Let's see. Yeah, you see that how many learning objectives, for 6.5. Now, so at this point, let's just take that first example in a book. Let's just brainstorm how can we solve an equation like that using whatever we have learned so far in chapter 6, okay? Or even something that so far since the beginning of the semester. So we're solving for the equation, right? And of course, the equation about x. I think that the first thought that should come to most of you guys will be, I wish that I don't have those sine, cosine going on, right? what if, oops, the equation looks like 5 x equals 3x plus radical 3. Would you be able to solve it? Okay. To get x, right? So, and that's called isolation of the unknown variable. But what now? We have 5 sine of x, which you don't know how much that is, equals 3 times sine of x equals 3 times sine of x plus radical 3. Your goal is to get to x, but sine is preventing you from getting to the x right away, right? Well, could you at least isolate the sine x for me, just like you did with the x? How would you do that? The same thing, right? So let's go ahead and subtract 3 times sine of x on both sides of the equation, like you always do, right? So now on the right-hand side, those two guys are gone. You're left with, well, can I simplify by combining these two terms? It's 5 times sine x minus 3 times sine x. You should get what? 2 times sine x, right? Equals to radical 3. All right, so now we're actually getting closer and closer to know what sine of x is, right? So sine of x should be radical 3 over 2. You guys agree? Just dividing out the 2, right? You know what? That's half the work. Yeah, because you're not able to get to sine x if you don't figure out what sine x is, right? So I'll probably give 2 points, 2 out of 5. If you just show me that, right? So now you're gonna have to try to earn, the next 3 points, right? So now the question is, from that fundamental equation, which is equating sine of x equal to a number, and you see that why they're using radical 3 over 2? It's a special, yeah, it's a very commonly used ratio, right? So now, how many of you at this point know what angle of x we're looking for? If you take sine of that angle, it returns radical 3 over 2. Logan? It is 60 degrees, right? Or, we prefer in radians. But, if you show me 60 degrees in the test, you're fine. All right. Let's say pi over 3, right? Well, in a right triangle, the angle x, right? The sine of x is opposite over hypotenuse, right? And you have the remaining side to be 1. And you see that 1 should be the opposite of a 30 degree, and therefore the adjacent side is 1, so the angle has to be. Anyway, now I said that if you're able to show me everything here, from here to there, right, you're going to get 2 points. You're going to get 1 more point if you show me the answer of pi over 3. You might say, what are the 2 remaining points? So that's the hard part of solving trig equations, because it has most likely infinite many solutions. Well, when I say infinite many solutions, doesn't mean that all the numbers are solutions. It means you have to tell me what numbers are the solutions. I know there are infinite many. You're going to have to tell me, how can I find them if I want to find every single one? I don't know. I know that the guy is called, what's his name? Blitzer, right? And he's in Miami-Dade, he's a professor. You can email him. Yeah, yeah, I'm thinking about emailing him because something in his book is, yeah. Now, but at least that the bottom line is, that those functions, sine and cosine, they're periodic, right? You know that when they hit a certain ratio, the angle doesn't have to be that easy, right? If you go round and round, you're gonna hit infinite many angles. You're gonna have the same exact ratio. So now what you could do is make sure that you get, some easy solutions. Then I'll teach you a little trick to get infinite many solutions, right? Let me draw a unit circle. And I want you guys to remind me, if I'm looking at a point on a unit circle, and let's say the radius connecting that point makes an angle of, let's say, theta. What kind of a coordinates I'm looking at for the point P in terms of theta? What goes to the horizontal coordinate? Is it sine theta or cosine theta? Cosine theta, right? Somehow it's not what you normally think, right? Sine theta goes first. It's actually cosine theta. And then you have the sine theta. Now, I want sine of something that is radical 3/2, right? Do you see that it's just by asking, where do you think that point is when its y coordinate is radical 3/2? Where do you think the point is going to be along the unit circle? Right? Well, I see that it has to be somewhere in the first quadrant, right? It's going to be an angle, and you know that's going to be 60 degrees. But would there be another point along the circle that could have the same exact y coordinate as the one I just plotted? Where do you think that point would be at, Mateo? Are you looking at somewhere down below? Over there? Okay. Now, it is in the second quadrant. And all I have to do is draw a horizontal line and let it intersect the circle, right? Why am I drawing a horizontal line? I want to make sure that it's telling me that the point is exactly at radical 3/2, right? So this segment here is radical 3/2. Now the question is, since we already figured out the angle here has to be, I know that you guys like degrees. Let's go with 60 degrees. Can anyone tell me what will be the angle associated with this point? Let's call it Q. And I'll say the angle is not acute angle. You guys realize that. The angle has to be the one that starts from the positive x going all the way to that radius. Next. How do you know it's 150? The thing is, maybe it's my fault. I draw this angle such a way that you thought that angle P OQ looks like 90. No, it's not necessarily 90. Amaya, what did you say? 120. Why is it 120? Okay, is it because you saw that the angle on the other side is the same as 60? But you're looking at from the horizontal, the positive x going all the way here, not quite getting to the 180, right? You're still what? 60 degrees away from 180. So therefore, you're getting that second angle, which is 120 degrees, right? Therefore, we have two possibilities for sine of x equals radical 3/2. It could be as easy as 60 or 120 degrees. Okay. Now, okay, good question. I'm glad you asked. Why is not infinite many? So now let's make them infinite many. No, Trust me, it will be as easy as just writing it in a funny way. So now let me ask you, don't you see that, point P actually represents infinite many angles. The one that you like to deal with is 60 degrees. But what if I let the thing to go around and back to the same point? I'm be looking at an angle much greater than 60, right? But how much greater? By 360, right? I can go another round, right? So I'll keep adding multiple 360 degrees, right? Well, what if I go the other way around? You'd be subtracting 360 from 60, right? So guess what? Now this is the fancy way to write the solution for both angles to make them infinite many. So you say that x is 60 plus 2n times 360. My bad, not 2n. n times 360. n times 360 degrees. Where n is plus or minus, or you know what, n could be 0, plus or minus 1, plus or minus 2, dot, dot, dot. Or x is 120 plus n times 360, and n is going to be, again, 0, plus or minus 1, plus or minus 2. That's all. For some problems, yes. Oh, yeah. But, if you forgot about the n, I'll assume that you know what n is, right? It's an integer, right? You see why I'm making either 0, plus or minus 1, plus or minus 2, because you could either add or subtract, right? It's you just adding, subtracting, multiple 360. But let's say if I give you extra point to award you for showing me the angles in radians, would you be able to do that? But it has to be right in the first place. So now, if I write the angle in the radians, what would it be like? $60 is pi over 6, pi over 3, right? Now, what is the radian for 360? 2 pi. So it will be 2n pi. All right, so that means it's either in degrees or radians. Now, for 120, well, that's 2 pi over 3 plus 2n pi. All right. Now, if the problem test doesn't require you to write things in radians or degrees, you're okay with either forms. But like I said, you have my word. If I see you get the right answer in radians, I'll think about get you the extra credit for being able to do so. Okay. Now, let me zoom out a little bit. I know that's a lot of work here. And that's why I said that solving equations are usually more labor intensive, right? But let's start with the first step by isolating the trig function, right? In this case, the sine of x, right? Is it hard for you to get the first 2 points? No, right? Everybody should get the first 2 points. Now, it's hard to get both answers, right? I guess that, with the calculator, you would have got 60 degrees, no problem, because you can use the inverse sine, right? You don't even have to remember the, special triangles. But how do we get the second solution? The unit circle. I know you hated it, I'm using the unit circle for so many times, right? But it is because I'm using it for so many times, using it for so many different occasions. You see how powerful it is, right? It's that single tool that usually going to save us in those tricky scenarios, right? And it's been consistent. To label a point, right, in terms of its x and y coordinates, but using the sine theta, cosine theta, sine theta, we are looking for sine of something equals to radical 3 over 2. And we realize that it will be 2 points that has the same exact y coordinate, which means that the angle 60 or pi over 3 is not the only possibility. You're looking at a second quadrant angle, right, which is 120 or 2 pi over 3. Once you're able to get those two angles, you're almost guaranteed to get the full credits, because there's no way you can miss just by writing that extra piece to let me know that yes, there are actually infinite many angles, right? But not all the angles, only angles that start off 60, 120, right? But they're off by a multiple of 360, right? We're not in a rush, at least for 6.5. But seriously, I want everyone to revisit this problem when they get a chance. And I think that there's a similar problem in a textbook, right? And also find out on the packet, I think that's going to be, question number 1, right? That's exactly the one that I worked out. And you go ahead and give it a try on the problem on the right-hand side, right? So see if you get it, okay?